Okay, this video is going to be a compilation of all the quizzes from the rationals unit. This is to help you prepare for the test. I want to make sure we went over these. Let's start on the rational graphs. I'm going to hop around to a couple different boards and whatnot. Let's start with the graphs. Okay, so what we got here is we got 1 over x plus 4, negative 2. So what I got to find first is my anchor point, which is negative 4, negative 2. Opposite there, follow there. So 1, 2, 3, 4, down 1, 2. Okay? And where that's going to be, now that's going to be where my asymptotes are. So there and there. Okay? So the asymptotes are x equals negative 4 and y equals negative 2. Okay? I can go ahead and put those in. The vertical one is x equals negative 4, y equals negative 2. Okay? Find some of the other stuff. We're going to go ahead and graph it. Okay, so I'm going to go over to menu. I'm going to go to graph. All right, I'm going to do 1 divided by x plus 4 minus 2. All right, I got to draw. Let me fix that. Okay, so that's what I got there. Okay, all right. So what I'm going to have there, I'm going to go ahead and do g solve root, which is negative 3.5. comma 0. Okay, so I'm at negative 3.5 comma 0, which would be somewhere in there. And then g solve y-intercept, which would be 0, negative 1.75. Should be right there, so 0, negative 1.75. Okay, and as you can see, I've got a curve going this way, a curve going that way. Key thing is don't pass over the asymptotes. Okay. We'll go like this, go like this, okay? Now, to do the domain, I don't think we have the domain on this one. Hold 1 second. Okay, there's no domain on this, so I'm just gonna, my hole is gonna be none, okay? If you're doing the domain, just to let you know, the domain would be all real numbers, but x couldn't be negative 4. The range would be all real numbers. Y couldn't be negative 2. They're the asymptotes, okay? All right, they're the asymptotes. So that's how you do number 1, okay? Number 2, what you have to do first is you have to factor this part. So I'm going to go into, if you need to use your calculator, please do. Go into equa, polynomial, degree 2, 1, 2, negative 3. Solve. All right, so that's x minus 1, x plus 3. Remember, you have to switch those. X minus 1, x plus 3. Now, what happens here is this and this cancel out. All right, so what that's going to be is the whole, okay, is going to be x equals negative 3. The whole is the solution to what you crossed off. So what I'm going to graph is I'm actually just going to graph that. So that anchor point right there is 1, 0, okay? So x equals 1, y equals 0, all right? Okay, that way, okay? So as I write this stuff in, x equals 1, y equals 0, okay? All right, there's my whole, all right? Now I'm going to graph it, go back into menu, graph. Now I'm just going to graph the part that was left over. 1 divided by x minus 1. And I'm going to draw. It looks like that. All right. G solve root. I've got no x-intercept. G solve y-intercept. 0, negative 1. So I got 0, negative 1 here. None for here. So this is what my graph looks like. It goes like this. Goes like this. Now, since I have that hole at negative 3, I find that curve and I put a little open circle there. If you were doing the domain would be all real numbers. Okay? The domain would be all real numbers, but x couldn't be negative 3 and x couldn't be 1. So it can't be the whole or the domain. The range would be all real numbers, but y couldn't be 0. That's the asymptote there. Okay? Moving down to number 3. All right, what you have to do first in number 3 is you have to take out the 6 and the 3. Okay. All right. So to find my asymptotes here, I find the anchor point. All right. The way I do this is I solve this. You could do it right here and solve that 3x plus 3, thinking about what that would be if it equaled 0. And that's going to be -1. And you can see that easily from there. To get the y coordinate, what you do is you divide those numbers out in front, or those numbers right here. So 6 divided by 3 is 2. So -1 over 2 up would be here. Okay, so that's x equals -1, y equals 2. Okay, so as I come down and do this, I got x equals -1, y equals 2. Okay, I'm going to go ahead and graph. All right, I'm going to go ahead and graph this. Now, what I'm going to do is I'm just going to go ahead and graph the original. Okay, you can always graph the original. Sometimes that's easier when you do it that way. So I'm going to do 6x plus 12 divided by 3x plus 3. Draw. Okay, g solve root. I'm going to -2, 0. That's about here. Okay, so I'm -2, 0. All right, g solve y-intercept. 0, -4 would be about right here. And so my curves go through this. Curves go through that. Okay. As far as holes go, you have none. If you were finding the domain, it would be all reals. X couldn't be -1. The range would be all reals. Y can't equal 2. Okay? Now, as you come over to this one is one you have to draw in the asymptotes. So as you can see, it's approaching that line. So I know it's going through that, and then it's also approaching this line. The key thing is using this intersection, which is 3, 1. So that means my asymptotes are going to be these. Okay? All right, it's very important to come up with that anchor point first, so go ahead and draw those in. So x equals 3, y equals 1. Okay? The x-intercept here, we can just look at the graph. It's going to be 2, 0. Okay? The y-intercept is going to be like 0, I don't know, 0.8 would be a good estimate. Okay? To find the domain and range, the domain would be all reals, but x couldn't equal 3. The range would be all reals. Okay? But y couldn't equal 1. Okay? From those asymptotes. To get the increasing, decreasing label, these are arrows here. So this would be -infinity. Now, this is approaching the dashed line of 1, of y equals 1. So that's why that's there. This is also approaching the dashed line of y equals 1. And that's going to be positive infinity. Okay? This is approaching the dashed line of 3. And that's going down, so that's -infinity. This also, let me move this down as you can see, this also is approaching the line x equals 3, but it's going up. Okay? To do the increasing, decreasing, all we care about are these x coordinates. Okay? And if I start here and trace, that's decreasing. Jump up here, that's also decreasing. So that is decreasing from, it's none for increasing. It's decreasing from -infinity to 3, and from 3 to infinity. Remember, 3 to infinity. Remember, only use the x coordinates. As x approaches infinity, okay? As x approaches infinity, y approaches 1. X approaches -infinity, y approaches 1. Here's a tip. That's always going to be the horizontal asymptote. Always, okay? For the end behaviors. All right? Now, I'm going to jump over to the other quiz, other part of that quiz. Let's see if I can find it here. Okay. All right. Graph has how many x and y intercepts? So pretty simple. We did pretty well with this on the quiz. What we want to do is we want to do x plus 1 divided by x. Okay, we want to draw it. G solve root. Okay, it's got one x-intercept, G solve y-intercept, and no y's. Okay, so one x-intercept, no y's, that would be C. Okay, which of the following describes the end behavior of this? Okay, so the concept here, all right, is we need to look at the horizontal asymptote. Okay, all right, and when we draw the graph for here, okay, we draw the graph. That's going to be x minus 6 divided by x squared. All right. So as you can see, it's approaching. The concept here is the graph is doing one of these, where it's approaching this line right here, which is the y equals 0 line. So that's what that's going to be, the horizontal asymptote. Okay? It says a function as a whole or movable discontinuity at x equals -4. It has an end behavior as x approaches infinity, y equals 4. What could the equation of the asymptote be? It is going to be y equals 4. Okay? So here's the key thing you have to figure out. End behavior and the horizontal asymptote are always the same. So as if it's approaching 4, that means it's y equals 4, okay? As far as the asymptote goes, all right? So it's a little fact you need to know. All right, so you can do this a number of ways. If you look at this, that's going to cross there at 3, 0. So what you can look at is which ones don't have anchor points there. Well, that anchor point would be -3 something, so that's out. That anchor point would be -3, that's out. So really I'm down to these last two, okay? All right. Now, if this one, all right, has 1 and 1, that would be y equals 1. Well, that's not that. Also, something you can look at is graphing them. All right, if I graph 8 divided by x minus 3, all right, and draw it, that looks closer to the picture. All right, I could also g-solve root. Okay, doesn't cross there. G-solve y-intercept -2.6. As you can see, that's about where that is. Now, if you go to the other one, we got x plus 1 divided by x minus 3. Okay, g-solve root -1. Well, that doesn't cross at -1. All right, so that's why this has to be your answer. All right. And then going on to here, identify the horizontal and vertical asymptotes. Okay, since I got an x and an x, the way that goes, 3, the solution of that would be 3. To get the y, 4 divided by 1 is 4. So it's going to be x equals 3, y equals 4. Now the key thing is you got to put them in the right places. The vertical asymptote is going to be x equals 3. The horizontal one is y equals 4. All right, don't let that, flip your mind around a little bit. All right, I took 2 answers for this. It says has a hole at -3. So what that means is if I've got a hole at -3, that means I got to cross off x plus 3. All right, well, which ones are doing that? Well, this one's not doing it, so that one's out. Okay, this one's not doing it. This one's doing it. This one's doing it. Okay, and this one's doing it. And the trick was here, and I didn't take off on the quiz, is if I took out a 2 there, that's also crossing out. So those 2 have been eliminated. Then it says an a vertical of -2. So that means that the solution out of this, if I have x and s, has to be -2. So here's -2 as a possibility. Here's -2 as a possibility. Okay. Here's -2 as a possibility. Here's -2 as a possibility. Okay. So all those still are in play. A y asymptote of 2. So remember, to get the y's when you have x and x, you have to divide the numbers in front of x. Well, that's going to be 1. That's y equals 1. So that one is out. Same thing here. 1 divided by 1 would be 1. So that one's out. This one right here would be 2 divided by 1, which would be 2. So that's a possibility. If you got that one, I gave you full credit. But also 2 divided by 1 here would also be correct as well. Okay? So a little bit tricky there on that one. All right? And I think that's it for that quiz. Let me hop over to the other rationals ones. Okay? Let me hop to this one. Okay? What you have to do on this is you have to, I told you to find the restrictions in the domain, and I want to go over that. If you need to, what you need to do first here is factor and reduce. So if you need to, go to menu, go to equa. Okay? Polynomial, degree 2, 1, 8, -20. Okay? So what that means is I'm going to be an x minus 2, x plus 10. Okay? This one's going to be 1, 11, 10, x plus 1, x plus 10. Now, a couple tips for doing this. The restrictions are anything left in the denominator after you've reduced, okay? So my restrictions here is x can't be negative 1, x can't be 10, okay? All right? So, the domain is pretty easy. The domain is going to be all real numbers, except x can't equal negative 1 and x can't equal 10. So whatever your restrictions are, that's what you make your domain. To get the simplified expression, I can cross off those two, and I'm left with x minus 2 over x plus 1. Okay? All right, move on down to this one. Okay? Now, what division does is it flips this second fraction. So what I'm going to do is I'm going to do 1, negative 20. Okay? So that's going to be x minus 5 and x plus 4. Now that's not going to be on the top over here. That's going to be right here. So don't get confused with that. All right? Do the other one. 1, 9, and 20. X plus 5, x plus 4. Okay? Multiplication. This side's already been reduced. Okay? This x squared, now that'll be 1, 0, negative 16, or you could just know that as x plus 4, x minus 4. Now there's a couple places you're allowed to reduce. You can cross off vertically, so I can get those gone. Cross off vertically, they have to be exactly the same. Diagonally, no, diagonally, no. Okay? So what I've got for a simplified expression here, okay, all right, is I've got x minus 4 times x plus 5 all over x minus 7, x minus 5. You cannot cross those two off because they're not exactly the same. Okay, same thing down here, all right? Now, since multiplication, okay, I'm going to take this in parts. I can just take out an 8 there. I'm left with x minus 2, okay? There's no GCF here on this one, okay? So that's going to be 2, 1, and negative 6. All right, for some of us, I did make this change on your quiz, so that should be a plus there. Okay, so what I got is 2x minus 3. Make sure you move that up and change the sign, so 2x minus 3. Okay, and that other one's going to be x plus 2. All right, when I factor a cube, I'm going to do that right here. Remember, I take the cube root of each part. So that's x minus 2. I put x cubed in there. That's going to be x squared, negative 2x squared. Now there's no x squared, so that's got to be positive 2x squared, positive 2x squared. That's negative 4x squared. I'm sorry. No, I'm sorry, that should be 2x. And that should be negative 4x. I don't have any x, so that's positive 4x, which is plus 4, minus 8. Okay? All right, go back and look at your other notes for that. What got tricky on this one here is you actually can take out a 2 first. So what I'm left with is technically 2x squared minus 13x plus 15. So when you do the factoring, you got to be careful there, is that there's going to be a 2 in that part. So it's going to be 4, negative 26, and 30. Solve. That's going to be x minus 5 and 2x minus 3. Okay? X minus 5 and 2x plus 3. Okay? 2x minus 3. Yeah, 2x minus 3. All right? So now I'm ready to eliminate. Can't cross off anything vertically. Can't cross anything vertically. Diagonally, this and this can go. Diagonally, this and this can go. Okay? So what I'm left with is 2, all of this stuff, x squared plus 2x plus 4 times x minus 5, all divided by x plus 2. Okay? Now, and 8. I got to divide the 2 and the 8. So that gives me 1/4. I'm going to have all that up top, x squared plus 2x, okay, plus 4 times x minus 5. And on the bottom, I'm going to have x plus 2. Okay. Right. Now, division. Let's take this one at a time. I got to take out a 10 there. Once again, what got tricky here is you had to take out a 2. Okay? So if I take out a 2 there, I'm left with x squared minus 11x plus 28, which to save some time, that's going to factor to this. Okay? Multiplication. Okay? These are going to flip, so what I got to figure out first is I got to figure out 3, negative 10, negative 8. Okay? So that's x minus 4 and 3x plus 2. Okay? Now, for this one, I got to take out a negative 1, so that's going to leave that as x squared minus 36, which is going to be x plus 6x minus 6. Okay? And now I'm going to see what I can cross off. Nothing vertical, nothing vertical. Diagonally, this can go. Diagonally, this can go. Okay? What I'm left with up top is 10, 3x plus 2. Okay? And then negative 2, x minus 7, x minus 6. And if I divide those, I'm negative 5, 3x plus 2, all over x minus 7, x minus 6. Okay? I would say one of the keys there for doing that, that part is make sure that you leave yourself plenty of space. Okay? Maybe factor on a separate sheet of paper would help. Okay? Now, let's go on to the back side of that page, finish this up. Okay, addition and subtraction, we have to find a common denominator. Now, what I have to do there is I have to take out a negative 1. So if I compare these two, this isn't missing anything, but this is missing a negative 1. Now, you got to be careful. When you multiply that, that's negative 5 times negative 1. So I got 12, okay. Make sure I'm doing the right one here. Hold on one second. Okay, let me scratch that for a second. I'm going to go ahead and, for the interest of this video, I'm just going to go through, oh, there we go. That's the one I wanted. All right, I thought that I made a mistake there. All right, so let's go back to this. So that's same deal, taking out a negative 1. So when that order is flipped, that's what you have to do, okay? So this side's missing a negative 1, okay? So that's negative 1 times 14, which is negative 14, minus 4 all over the common denominator. To subtract those, negative 18. My common denominator is negative 1, x minus 6. Or, if you want to, you could have written it like this. Okay? Either answer would have been acceptable. Okay? Moving on to number 2. On this one, I got to take out a 2. I'll be left with this. Okay? On this side, it would be x plus 9, x minus 9. If you need to use equa for your calculator, do that. This side is only missing x plus 9. So I got to multiply that by the top. This side is only missing 2. Okay? It already has those other things. So as I distribute that, that's going to be 7x squared plus 9x plus 20x. Okay? All over my common denominator. Okay? All over my common denominator. All right? So what I'm going to have there is I'm going to have 7x squared plus 29x over 2 times x plus 9 times x minus 9. Okay? All right, moving right along. Okay, once again, I'm going to go ahead and use equa for this. Okay? I'm going to use equa for this. So 2, 9, negative 5. Solve. I'm going to have 2x minus 1. Okay? So I got 2x minus 1, x plus 5 on this side. On the other side, okay, I'm going to do 5, 28, 15. Okay, that's going to be 5x plus 3 and x plus 5. Okay, so I got to look at what's this side missing. The only thing this doesn't have is 5x plus 3. Okay, what is this side missing? Well, 2x minus 1 is the only thing this side is missing. Now, when you distribute you got to treat that like a negative 3. So what I got is 40x plus 24. Negative 3 times 2x is negative 6x. Negative 3 times negative 1 is positive 3 over my common denominator. The x's would combine to 34x, and the numbers would combine to 21, all over, okay, 2x minus 1, x plus 5, 5x plus 3. Okay? All right, so on number 4 here, I got to take out a 2, that's going to be x plus 3. I'm going to use equa. In the interest of time, I'm just going to go ahead and factor that for you. If you want to, just use equa, switch the factors around. What's this side missing? X minus 7. X minus 7. What's this side missing? The only thing it's missing is 2. Okay? It's got the other things already. Okay? Now, what I have to do with that is I have to multiply that out using boxes. X squared, negative 2x, negative 7x, 14. Okay? So that's going to combine to x squared minus 9x plus 14. Okay? Negative 14 times 2 is negative 28 over my common denominator. If I combine my like terms, x squared minus 9x minus 14 all over 2 times x minus 7 times x plus 3. Okay? So that's how the multiplication there you had to do. Treat that like a negative 14 when you multiply. Okay? Number 5, and the final problem here. This is okay up here, but I'm going to have to treat this like a separate problem. So this side is missing x minus 4, so I got to multiply by the top and the bottom. This side's not missing anything. So what I got is I got 3x minus 12 plus 6 all over my common denominator. So that's going to be 3x minus 6 over 5 times x minus 4. Okay? Now, what this really is a fancy symbol for division. So what I'm going to do is I got 3 over x minus 4. I'm not going to multiply. I got to flip that. Okay? I got to flip that. So that's 5 over x minus 4. Okay? And this is 3x minus 6. Now, if you wanted to, you could have written it like this. Okay? Either way. But I can easily eliminate there. If I multiply across, I accepted these answers. I accepted 15 over 3 x minus 6. Or if you wanted to, you could have divided the 3 and the 15, which would have been 5 over x minus 2. Either answer I would have accepted for that. A couple skills I think you really need to watch. Make sure you know how to use equa. Okay? So make sure you know how to make that into 5x plus 3. Moving that up, changing that sign. Okay? Knowing how to type that going in across. Okay? Understand that addition and subtraction, okay, you have to find common denominators. For the other problems, okay, when you get into stuff like this, division and multiplication, you have to factor. If it's division, you've got to flip that second one, okay? Watch your GCFs, okay? If you go through that and the sample test, a combination of that, you should do well on this test.